Hi everyone, so you're very welcome to today's Saturday session with ExamRevision. My name's Robert and I'm going to be taking you through some stuff on Leaving Cert Chemistry. In particular today, we're going to focus on two things. We're going to focus on the structure and layout of the Leaving Cert Chemistry paper for this year. And then we giving you some hints and tips, I suppose, along the way. And then we're also going to look at our equilibrium calculations that can come up in the equilibrium question. So you're very welcome along. For today's session, you'll need a pen and paper. We're going to be running through some calculations, and I find it's quite handy to run through the calculations as I'm doing them, so you can follow along and also take some notes as you go. These notes will be available to you after the session. So make sure you fill in the required Google form to receive the notes. And if you have any questions throughout the session, feel free to send them on to us and I'll try my best to answer them either before or after the session. So let's get going. We don't want to keep you for too long on this lovely Saturday. So as I said, the first thing we're going to look at today is the Leaving Cert Chemistry exam for 2022. And in 2022, the exam will have the following layout. There will be two sections, Section A and Section B. Section A will have 3 questions and Section B will have 8. And this year, you are allowed to answer any 6 questions on the paper. So you don't have to answer a specific amount from each section. You can answer any 6. Each question will carry 50 marks, giving a total of 300 marks for your paper. So when it comes to exam paper timing in Leaving Cert Chemistry this year, you will have 3 hours to complete your exam, and that totals to 180 minutes. So I recommend that you take 10 minutes at the start of the exam to have a read through, pick some potential questions you might do, look for questions that you definitely don't want to do. Maybe there's some topics that you're not doing, so you'll want to eliminate those straight away. So that 10 minutes at the start is to settle you in, getting you reading the questions and trying to figure out what ones you're going to answer. Then I've given you 10 minutes at the end, and this 10 minutes at the end is just to, again, give yourself time to process everything you've done in the exam at the end, to maybe go back if there's anything you want to add to certain questions, as you may have skipped some questions as you went along, or skipped some parts that you might want to go back and fill in. And then I've allocated 25 minutes for each question. So that should be loads of time for you to think about your questions, think about the answers, make sure you're including all the necessary keywords, etc. in your answers. Now, this structure of timing will also leave you with 10 minutes to spare at the end of your exam. So this 10 minutes is just if there's any loose ends that need to be tied up, but it also allows you, if you need an extra minute or two on certain questions that you're doing, that you have that leeway there, I suppose, and cushion to fall back on. If you happen to go over time, let's say, for example, you make a mess of a calculation and you need to start it again, you have this 10 minutes to play around with. Now, it is important to remember that all questions will carry equal marks, so you shouldn't really be spending, 40 minutes on one question and only 15 on another. You should really be spending the 25 minutes on each question, and once you've that done, move on and try the next question. Secondly, I would be recommending that this year you answer 6 or 7 at most questions on the paper, because what you need to remember is you only get marks, all of your questions will be marked, but only your best 6 will count. So marks for best 6 counted. So if you go and do 8 questions on your exam, that's 2 questions that you're spending time doing that aren't going to be included in your final marks. So it would be much more worthwhile to you to put as much time as possible into the 6 questions that you're going to do, get as many of those answers correct as you can, and ensure that you're getting all the keywords necessary for those questions. So I wouldn't be recommending that you do any more than 7 questions. And even at that, a 7th one, technically it is a waste, because you're not going to be using that question, one of the questions then in your exam as a result. So it is kind of wasting time. So you'd be better off to go and put as much effort as you can into the 6 questions that you've chosen on the exam. Now, if we take a look at the breakdown of the paper, section A, there's 3 questions in this section, and all of these are experiment-based questions. So question 1 will be a titration, and that could be an acid-base titration, a redox titration, or a water titration. Question 2 will be based on organic chemistry experiments, and question 3 is any of the other experiments that have not already been assessed on the exam paper. Now, it is important, I suppose, to note that in recent years, question 2 and question 3 have consisted of multiple experiments. So consisted of multiple experiments. So in the past, their question 2 and question 3, they've brought up maybe 2 or 3 experiments and assessed you on different parts of those. So it's important that if you're doing any of these experiment questions, that you know them all and that you don't leave any of them out. So let's take a breakdown and look at these questions individually then. So question 1, as we said, it's your titration question. The first thing you should definitely know how to do in a titration question is you should definitely know how to make a standard solution. Doesn't matter what they ask you to make a standard solution of, the process will be the same all the time. So this standard solution question in particular is definitely going to be assessing your titration technique and how you use your equipment. So what to rinse your equipment with. Do you rinse it with deionized water and the solution it's to contain, or just deionized water, making reference to the bottom of the meniscus in line with the graduation mark. If it's a colorless solution, top of the meniscus in line with the graduation mark. If it's a colored solution, etc. They're the kind of things that they would be looking for in your standard solution of sodium carbonate. So along the theory lines of that question, you know, I'd be including keywords like, you know, when you're transferring solutions into volumetric flasks, you're using funnels. You're using droppers towards the end of the experiment to get the bottom of the meniscus in line with the graduation mark. So all of those pieces of theory and those titration technique and equipment technique are essential in these questions. Other titrations then, after your standard solution, you may be asked to use the standard solution of sodium carbonate to find the concentration of HCl. That tends to be a little bit more of an ordinary level question. But it can come up at higher level. Similarly, for question 3, using a standardized solution of HCl, work out the concentration of NaOH. Again, more ordinary level geared, but could potentially come up, so just to be aware of that. Question 4 then, or titration number 4, is when we start to get into the real higher level stuff. Here you've got your ethanoic acid in vinegar, and then you have number 5 there is your water of crystallization in hydrated sodium carbonate, which is your washing soda titration. So those first 5 there are all from the acid and base chapter. Apologies, that should be the highlighter there. So these are all from the acid and base chapter in the yellow. The next batch then are your redox titrations, and I'll highlight these for you in your blue. So this is 6, 7, 8, and 9. These would all be paired together. So 6 is to use a standard solution of ammonium iron 2 sulfate to standardize a solution of potassium permanganate, and 7 then is your iron tablet. So if I was to do a breakdown within this, I would be saying that 6 and 7 are very similar because they both involve the use of KMNO4 or potassium permanganate. So they will both involve similar color changes. So that is worthwhile to know that they can be linked up and that color change, make the connection with the color changes. Similarly, 8 and 9, I would connect up. So if we look at number 8 says to prepare a standard solution of sodium thiosulfate and standardize it with a solution of iodine. And then number 9 is to determine the percentage weight per volume of sodium hypochlorite in bleach. Both of those involve iodine and iodide ions and sodium thiosulfate. So that's why I would pair those up. And they're your redox titrations. The last two then here, 10 and 11 on the bottom, I'll highlight them in green for you. These are your water titrations. So in your water titrations then, you have the EDTA, which is measuring water hardness, and BOD, which measures the dissolved oxygen present in the water. Now, top tip for your titrations, you most certainly should know your indicator, and you should also know your color change, and calculations should be undertaken using first principles only. So you shouldn't be using the formula at higher level. It hasn't worked in previous years. It has worked in one of the years, but it was very complicated to use, and first principles was much easier. So if you're looking for more information on first principles calculations, you can check that out on examrevision.ie. I'll show you the website before the end of our session today, and you'll see that I have examples of first principles done out for all of these titrations. So that would be very helpful for you. And again, they're all exam questions that are done out as well. So that's titrations, that's question one. Question two then is your organic chemistry experiments. And these are definitely ones that you should know very well. There's a lot of small details in them that need to be known, and a lot of tips and tricks for those. Again, that's gone through on the ExamRevision website, so you should maybe have a look on there. And if we go through them, number one and number two, it's ethene and ethyne, and examine their properties. So you should be very, very familiar with that experiment there. This the two easiest organic chemistry experiments that we have in our course. So it would be worthwhile taking a look at those. The heat of reaction of HCl and NaOH, that is thermochemistry. And that's your polystyrene cups and measuring the temperature rise. And again, there's a calculation involved in this one, where you find the heat liberated and then you find the heat of reaction consequently for that by figuring out the concentration of the acid that you've used. So that is an important one. Then we move into the more heavy organic, as I call it. So number four here, the extraction of clove oil from cloves and its isolation. So that would be steam distillation. There, I'll write that down for you. This would involve steam distillation, but it would also involve liquid extraction. So that's important to know as well. You're washing with cyclohexane, etc. So that's important to know for that one. Then number five, you've got your preparation of soap, and the preparation of soap, then I suppose key things would be reflux in this, your distillation, and then I suppose you should know how it can be precipitated using the brine, etc. So there are just a few tips on that for you. Number six, then, this is all of your benzoic acid together. So you've got the oxidation of phenol methanol to benzoic acid. That's your production of benzoic acid. Then you have the recrystallization of it, and you have the melting point. So I'll underline those: recrystallization, melting point, and then oxidation of the phenol methanol would be the production. Okay, so the three of those would come up together. And you know, they should be known very well. 7 and 8 then, properties of ethanol and the properties of ethanoic acid. And finally, chromatography as number 9 there. Again, chromatography will be paper chromatography, HPLC, etc. Some tips for the organic experiments. If you're doing question 2, you should definitely know how to calculate the percentage yield. So actual yield over theoretical yield, and then how to find that theoretical yield. That would be very important for these calculations. And similarly, you should know your reagents and your catalysts, and you should be able to label those accordingly. So if a question asks you what is the reagent and what is the catalyst, you should label those. Reagent equals, catalyst equals. So you should know those for these experiments in organic. Question 3 then, that's referred to as the other. And this is basically any experiments that will not have appeared in questions 1 and 2. And this includes the flame tests, redox reactions and displacement of metals, the tests for anions, the relative molecular mass of a volatile liquid. Then I would be pairing 5 and 6 up together if you're revising. These are from the rates of reaction chapter. So I suppose I could actually just highlight those in red, couldn't I? Looking basically at the production of oxygen from hydrogen peroxide using manganese dioxide as a catalyst, and similarly studying the effects of the rate of reaction, the effect the concentration and temperature have on the rate of our chemical reaction. The next one then, number 7, is Le Chateliers Principle, and that's your simple test tube experiment. You may have done it with iron and potassium thiocyanate or whatever. Although this is an equilibrium experiment, we are not going to go through it today. Today's session is purely going to focus in part 2 of the session on the equilibrium calculations. I would be grouping together then 8, 9, 10, and 11. These are water experiments, but they're not titrations. So you've got the determination of free chlorine in water using a comparator, determination of total suspended solids, total dissolved solids, and pH from a water sample. So I will be popping all of those together into one group. Now, although I haven't really looked at predictions for this year, flame tests and the test for anions came up last year in question 3. So that threw a lot of people. It was unexpected, but here at ExamRevision, it is what we predicted to come up. So keep an eye out for that later on in the year. We got all 3 experiments right last year in section A. So they may be ones that you could put on the back burner this year if you wanted to. But again, with this having only to answer 6 questions this year, if you're picking the experiment question, the top tip I would have for you is know them all. Don't leave any out, because if you do, you're setting yourself up for a possibility that you won't be able to answer the question. So just to be aware of that leaving out experiments, although certain ones have come up last year and it may be less likely that they come up again, that doesn't completely rule them out, and they may also appear in another part of the paper. So just that you're aware of that. So that's section A complete. If we move on to section B, then section B is made up of 8 questions. And in this, we have questions 4, questions 11, and question 10. These all have internal choice, meaning that there is parts in it that you don't have to answer and you could still get full marks. And then questions 5 to 9, there's no internal choice. So that means you have to answer those questions completely in order to obtain your full marks. So let's look at these in closer detail. So for question 4, 5, and 6, for question 4, there is 12 parts and you only have to answer 8 of them. Part L of this question would be from the option. So if your teacher has not completed the option part with you, which would be on either electrochemistry or industrial and atmospheric chemistry, if that hasn't been completed, there is only 11 parts that you can possibly answer here, but you still only have to answer 8. So that gives you some wriggle room there. A top tip for me for question 4 for you would be to answer as many parts as you can of this question. There's no negative marking in it. So if you answer 10, you can afford to get 2 of them completely wrong and still come out with full marks at the end. So I think that's a good question to do. The only thing is with question 4, in particular, question 4 would be looking at definitions, and it will be looking, I always say to my students that question 4 looks at the small stuff on the course. So if you're interested or know a lot of the, the nitty gritty things about color changes, maybe assigning oxidation numbers, stuff like that, this is a question for you. So have a read of it. And all I will say to you is do not touch question 4 if you can't answer 8 parts. If you can't do 8 parts, don't touch it, because straight away the question is worth 50. If you're not able to answer 8 of them, you're automatically losing marks. So let's say you're only able to answer 7, you're automatically only going to score a maximum there of 44. So it's very important. You must know 8 answers in order to answer question 4. Question 5 then, atomic theory, periodic table, including trends, bonding, and radioactivity. This question here is usually very specific, particularly looking at marking schemes in the past. They're very particular with answers, only certain keywords are accepted, etc. So this is a question that some students may find difficult. They think that it's easy, but it's actually quite difficult to get marks in this question. That's not me trying to tell you not to do the question, but just to be aware that you need to have a good eye for detail and good use of keywords in your answers in question 5 to obtain a good mark in that question. Question 6 then is the first of the organic questions, and it's fuels and thermochemistry. And a top tip I'd have for question 6, there's definitely going to be a calculation, and it's either going to be Hess's law or heat of neutralization. So I would recommend that you know both of those calculations inside out. And there is Leaving Cert higher level exam samples of these questions done out for you on examrevision.ie, which I'll show you before the end of the session. Just to be aware in here as well, that in question 6, as part of this thermochemistry part of it, you could be given the heat of reaction experiment. So it's just important that you know that it could appear there as well as appearing earlier on in the paper. If we move on to questions 7, 8, and 9, then one of these questions, usually question 8, will be an organic chemistry question, and it will be based off the families and reactions. So here I will be saying it's very important to know your families. And when I say know your families, I'm referring in particular to knowing your functional groups. I would always start off maybe drawing some of the structures that might be given to you on the paper. You should know the reaction types, and you should know the reagents and catalysts. And as I've said already, these should be labeled very clearly. When it comes to your reaction types, don't forget that you need to know the mechanism of an addition and substitution. So for addition and substitution, you need to know the mechanism, but for the rest of the reactions, it's just identification. Just that you're aware of that. So that's usually question 8. Then question 7 and 9, which are the other 2 questions, would be made up of the following topics, but not limited to. This is just in the past, the key topics that have come up here: rates of reaction, equilibrium, water, acids, bases, and pH. And we'll focus on the equilibrium bit in a few moments. If we're looking at further down then for questions 10 and 11, as I said, these are ones that have internal choice. Question 10 will have 3 parts, of which you have to answer 2. And it's highly likely that one of the parts of question 10 will be a pure stoichiometry calculation-based question for 25 marks. That's quite a frequent and quite a common thing, that one of the parts in either question 10 or 11 is usually a complete stoichiometry calculation for 25 marks. Question 11 then is 4 parts, of which you have to answer 2. But part D, or the 4th part of this question, is from the option. So again, if your teacher hasn't completed the option with you, you have 3 parts of which you can answer 2. So just to be aware of that. Typical topics that appeared in question 10 and 11: atomic theory, equilibrium, acids, bases, pH, stoichiometry, you're nearly guaranteed 25 marks in there, water, electrochemistry, there could be some organic in there, lots of properties of gases comes up, and oxidation and reduction is usually a very good one in there. So I would definitely be addressing oxidation and reduction, and I'd definitely be addressing stoichiometry, because the oxidation and reduction anyway is needed for your titrations in question 1, and your stoichiometry is needed across your paper, but there are 2 parts that tend to come up quite frequently in this section of the paper. So some top tips in general: it's quality over quantity. You should answer 6 questions only. If you are doing an extra one, I would say 7 at most, okay? Because again, every time you do a question that is beyond the 6, some of the work that you've done isn't going to be counted in your marks. And to me, that's a waste of exam time. You'd be better off spending your time maybe thinking of more points or more pieces of information that you could write down for your 6 questions that you've done already. It's very important to show all of your steps in your calculations. And here we will be making particular reference to showing the steps in molecular mass, because you will lose 3 marks if your answer is incorrect for your molecular mass and no working is shown. Where you'll only lose 1 mark, it's called a slip, if you show the working for your molecular mass. So never skip any steps. Make it as easy as possible for the examiner to give you marks. You want the examiner to be able to give you the marks, so write down everything. If you draw diagrams, they should be fully labeled. They should have a minimum of 5 labels on it, is what I would recommend, in order to ensure you're going to get the marks for it. Be careful of questions that say with the aid of. If it says with the aid of a diagram, that to me would be indicating that you are going to at least need a diagram for at least 3 marks. So if you see with the aid of a diagram, ensure to include a diagram. And it's very common, I see when I correct students, don't include a diagram and they're automatically down their marks then. For graphs, make sure that you draw your graph on graph paper. Quite a lot of mocks came back this year. And from correction of them, I saw students weren't drawing their graphs on graph paper because rates of reaction came up in one of the mocks this year. And the students that didn't draw the graph on the graph paper lost 3 marks. So simple things like that to that cost students grades there. And that's what's going to separate H1s and H2s, small little things like that. The booklet for your Leaving Cert Chemistry exam will have graph paper in it already. There is pages of graph paper stapled into it, so make sure to use them. It's important to answer what you're asked. When I say that, I basically mean read the question carefully. And it's very common that you see some questions have multiple unlabeled parts. So for example, part A could have maybe 3 questions in it, and students just do the first part and then they move on. So they'll do part A, it could be what is the color change and why does the color change occur? A lot of students would just do the what part and leave out the why. And again, that's thrown away silly marks. Last thing then, neat and tidy layout is favorable. Remember that when the correctors are correcting this, they are on their holidays themselves. And although this is work for them and it is a job, they aren't going to want to have to, you know, figure out what you're trying to say by reading messy writing. And you know, if things aren't labeled properly, to having to go and figure out what part of the question is this, it can be very frustrating for an examiner, and that's not going to keep them on your side. So neat, favorable layout, questions fully labeled, you know, question 1, part A. And I would also say start a new question on a new page. So if you're starting a new question, put it onto a new page, title at the top, question, whatever, and work through. You know, you're given a full booklet. That booklet is going to, you know, you're not going to be able to pull some of the paper out and reuse it for another time. That booklet is yours, so use as much of it as you can. Leave loads of space for diagrams, etc. And secondly, last thing I suppose is if you leave out some parts of your questions, make sure and leave a gap that you can go back and fill it in. Okay, so that's it for the exam paper layout. So what we're going to look at now is we're going to move on to part 2 of our session today. And part 2 of our session today is on equilibrium calculations. So I'm going to give you a brief background into the theory of equilibrium. We're not going to spend too much time on it. If you want more knowledge and background on the theory behind equilibrium, you can find lots of videos on the ExamRevision website, and I'll show you that before we finish off the session this afternoon. This will mainly look at the calculations, but I'll give you just a brief introduction to equilibrium just to set the scene. And don't forget, if you've any questions, feel free to ask them and we will try our best to answer them for you. So, equilibrium, an introduction. What is equilibrium? So equilibrium basically means a state of balance. Okay, so I do always say equilibrium is like a seesaw. And if you do something to your reaction, the left side of the seesaw is the reactants, the right side is the products. If you do something to your reaction, whether you be it heat it up or change concentrations, it's going to cause your seesaw to sway towards one side or move towards one of the sides. Okay, so at equilibrium, we would say this is your definition. And this definition would be very important. You should know it word for word in order to be able to obtain full marks. Chemical equilibrium is a state of dynamic balance in which the rate of the forward reaction is the same as the rate of the backward reaction. Now, we know that many chemical equations do not go to completion. And if a chemical equation or reaction doesn't go to completion, often it is referred to as a reversible reaction. And with our definition, as we have down here, a reversible reaction is a reaction in which once the products are formed, they react to produce the initial reactants. So with a reversible reaction, you would be familiar with the following arrows that I've just drawn on the top of the screen there. And the top arrow is basically indicating that we are going from producing our reactants to producing our products. I'll go with R and P like that, reactants and products. And this bottom part of the arrow here is indicating that the products are decomposing or breaking back down to produce your reactants. And this is what we mean by a reversible reaction. So the reaction never actually goes to completion because your reactants are reacting to produce your products, but then the products are breaking back down to produce your reactants. Now, this all is very important when we look at Le Chateliers Principle. Now, we won't be going into this in detail today, but just to give you a definition of Le Chateliers Principle, Le Chateliers Principle states that if a system at equilibrium is subjected to a stress, the system will alter to oppose the effect of the stress. So an example of that would be if you heat up the system, or if you apply heat, the reaction is going to want to cool down. So if you have that, a cooling reaction will occur. You can apply a stress to an equilibrium reaction in 3 ways. So you can change the concentration of either a reactant or product, you can change the temperature, or you can change the pressure. But the important thing to identify here is if you're changing the pressure, the system must be all gases. If they're not all gases, you can't change the pressure, okay? If they have to be gases in order for you to be able to change the pressure. Now, if you want more information on the Chateliers Principle, including the experiment that's linked with that, you can find that on ExamRevision.ie. So, here we have 2 examples of equilibrium reactions that again are gone into more detail on the ExamRevision website, and they're the Haber process and the contact process. And the Haber process is for the production of ammonia. So we can see here that nitrogen and hydrogen are reacting to give us ammonia, but also consequently, because of our reversible reaction arrows, we can see that this ammonia here can break back down to produce nitrogen and hydrogen again. Similarly, for the contact process, it's mainly linked with the production of sulfuric acid. We have sulfur dioxide reacting with oxygen to produce sulfur trioxide. And sulfur trioxide is one of the key components in the production of sulfuric acid. But once the sulfur trioxide is produced, there is a possibility that it can break back down to reproduce your reactants. And these are examples of 2 reversible reactions. So let's move to equilibrium constant. This is what we want to work with today. These are the calculations that we're going to go through. So equilibrium constant, the first thing is equilibrium constant takes the symbol Kc. So you may see that on an exam, calculate the Kc value. Kc just basically means equilibrium constant. And we can see here that we have a formula for Kc. I'm just highlighting it in yellow now. And this formula for Kc is based off the reaction that I am just highlighting here in blue that is beside the formula. So if we read the points underneath, it helps explain what each of these mean. So as you can see, we have square brackets here in our formula. So the square brackets are basically telling us that the concentration of the reactants and products are measured in moles per litre. And this is important because moles per litre, you need to be aware if you're given a question, you need to ensure that your volume at the end is in litres. So for example, if you had a question that told you that an experiment was carried out in a 10-litre container, you would have to divide your volume by 10 in order to ensure you would get it to moles per litre. So just to be aware of that and to remember that, but we'll see, I've done a table for you that will help you remember this. If we take a look here, we can see that C and D are at the top of our reaction or our equilibrium constant formula. And we can see that C and D are our products. And that is true for all of the time. Products are always written in the numerator and reactants will always be written in the denominator. So that basically means products on top, reactants on the bottom. And we can see that here we've got our products on the top, and we've got our reactants on the bottom. Now, you will see that the concentration of each of our species that we have, or each of our elements or compounds or molecules, is raised to the power of its coefficient from the balanced equation. So you will see here, I might be able to highlight them in green for you, that the small letters here, the coefficients, are in your powers up here in your equilibrium constant formula. So it's just important that you are aware of that, and that the capital letters refer to the actual molecules themselves that we'll be measuring the concentration of in moles per liter. Now, when you calculate equilibrium constant, you will get a value. The value of the equilibrium constant Kc, it indicates whether the reaction has proceeded very much towards the products or whether there is very little conversion occurring. So, i.e., it tells us if the forward or backward reaction is favored. Okay, so some pieces of information for you here. If the Kc value is very large, i.e. it is a lot bigger than 1, we would say that the concentration of the products is large and equilibrium lies to the right. And you may have learned that in school as the forward reaction is favored, meaning that we have lots of products being produced. If the Kc value is very small then, i.e. it is a lot less than 1, we would say that the concentration of the reactants is large and the equilibrium lies to the left. And I'm sure you've guessed it by now, that would mean that the backward reaction is favored. And finally, if your Kc value is close to 1, we would say that the concentration of the reactants and products is nearly equal. So they're just important to bear in mind when we're doing our calculations for this equilibrium chapter. So here is an example of an equation, an equilibrium reaction, and I've written out the Kc formula for you underneath to help you identify each of the parts. So as we've said already, the square brackets is indicating the concentration in moles per liter. And as we can see, we have our product on the top and we have our reactants on the bottom. And you can see that the coefficient of each of these is in the power. So we can see that we have 2 ammonias, so that's the product is squared on the top. For the nitrogen here, there's a 1 in front of it, and we just never write it down. But if there's no number in front of any molecule, you would assume that there's 1 of them. So we can see here that we don't really write a power, but you could put into the power of 1 here if you wished. And finally, we can see that the 3H2, we can see that the 3 is raised to the power of your H2 there. So that is how you would find, that's how you would write the equilibrium constant formula for that reaction. If you wanted to do a calculation on it, they would obviously have to give you concentrations to work with, and that's what we're going to look at now. So when you're calculating your equilibrium constant value, you should never deal in grams. You must always deal in moles. So that basically just means that if you're given grams, make sure to divide by your molecular mass to get it into moles before you start filling into the rice table that I'm going to do with you now. So as I've said, we'll be doing a rice table, R-I-C-E, and rice stands for R meaning reaction, I meaning initial concentration, C meaning change, and E meaning equilibrium. And we will write out this table in each of the calculations that we do, and you'll see that it's very similar all of the time. There's 2 types of questions then that you could be asked in the equilibrium chapter. You could be asked to calculate the equilibrium constant, and that's type 1, when you're given information on the concentrations, or type 2, you could be asked to calculate the concentration of the reactants and products when you are given the Kc value, and that's type 2. We're going to do one exam question for each of these types today to show you the structure and how to approach them. So let's begin. We're going to look at type 1 first. So type 1, this example comes from the 2021 paper. It was question 9C, and you can see here that the equilibrium calculation was worth 21 marks. So that 21 marks meant that this question was worth 7% of your full paper if you chose to do the equilibrium calculation. So if we read it, it says when 9 moles of nitrogen and 27 moles of hydrogen were placed in a 10-litre container, there were 6 moles of ammonia present when equilibrium was reached. Now, one thing that I didn't write in here in this question, I didn't screenshot it when I was putting it in, was the actual equation. So this is the equilibrium equation that's in question for this question here. So you can see that it is the equation for the Haber process because it is with the production of ammonia. So the first thing we would need to do is to write the equilibrium constant. Then we would go and calculate that equilibrium constant, and then a little add-on question at the end to find the percentage by volume of ammonia in the container at equilibrium. So let's try this question. So I've just put the question up here in the top left-hand corner for you, and just for myself that I can see it as we go along. So let's start with part 1. I'm going to do part 1 up here. So part 1 asks you to calculate the Kc value for the reaction. Now, this is the reaction here. The reaction is N2 plus 3H2, and it goes to 2NH3. So we know that for our equilibrium constant, it's going to be called Kc, and we know that we have our products divided by our reactants. So we need our square brackets and we put our product into it. So our product is ammonia, NH3, and that is raised to the power of 2. So that's squared. Divided by, you put the concentration of your products in moles per litre raised to the power of their coefficients. So that's N2 to the power of 1 by H2 to the power of 3. So that is the equilibrium constant formula for, or expression for that reaction. So that's part 1 complete. So for part 2, they're asking you to calculate the Kc value. Now, when you're asked to calculate the Kc value, I always use RICE or ICE. And we know that RICE or ICE, the R stands for the reactants. So let's fill in the equation. So for the reactants, we've got N2, 3H2, and then we have our product, which is 2NH3. Now, what I am just going to note in red on the top here is the ratio. This is a 1:3:2 ratio, and this will be important when we come to do a little bit more on the calculation in a moment. So our reaction, you write out your reaction for the question. I stands for initial. Another word for initial is start. So you write down the concentrations that you start with. So it tells us in the question that we have 9.0 moles of ammonia, and we have 27.0 moles of our hydrogen. Now, at the start of any reaction, there will be 0 moles of your product. So we write in 0 underneath our ammonia. So I would always say, if you're being asked to calculate the Kc value, skip the change line and go straight down to the equilibrium line, which is E here. And it tells us in the question that there is 6.0 moles of ammonia present at equilibrium. So I can see here 6.0 is present at equilibrium. And this one piece of information is the ticket to finishing the whole question out. So you need to make sure that you spot that in the question. It said up here, it said there were 6 moles of ammonia present when equilibrium was reached. So that means at equilibrium, you have 6 moles. Now, let's take a look. How did we go from 0 to 6? You would have plus 6 moles. So my change for my ammonia is +6, meaning that +6 moles were added during the process of this reaction. So consequently, now we will go and figure out the concentration of our reactants. With your reactants, the concentration of your reactants is going to decrease in both cases because the reactants are reacting together to produce your product. So obviously some of them are going to have to get used up because neither of them are catalysts. So because they're getting used up, that will go forward to produce your product. So that's why I'm putting a minus in straight away. Now, if I have, I'm going to do it over here. I've told you I have a 1:3:2 ratio. Now, when the ratio is 2, I had 6 moles of ammonia. So what I would say, in order to figure out the rest of your ratios, you need to do a little bit of maths. So to figure out the ratio of 3, I would be doing 6.0. I would divide it by 2 and multiply it by 3. So I'm dividing by the original ratio of 2 and multiplying by 3. And similarly, for the ratio when it's 1, I would be doing 6.0 divided by 2 and multiply that by 1. Now, when you do that, what you get is you get 6.0 is to, sorry, you don't get 6.0, you get 3.0 because you've divided by 2. 3.0 is to 9.0 is to 6.0. So that is your line for your change now. So we know that the 3 represents the hydrogen, so that's minus 9.0, and the nitrogen is 3.0. So basically what you do is you use the change that you have, and then you look at your ratio to work out the volumes of the rest, or the concentration change of the rest of them. So because 6 moles represented 2, if you divide that by 2 and multiply it by 3, you can figure how much of the hydrogen depleted. Similarly, dividing by 2 and multiplying by 1 will tell us the amount of the nitrogen that depleted. So to figure out your equilibrium then, you just put these together. 9 minus 3 is 6, so 6.0, and 27 minus 9 is 18.0. So now I figured out all of my concentrations at equilibrium. But let's go back and take a look at the question. The question tells us up here that this is for a 10-liter container. So we know that we want to get our equilibrium concentrations. We know if the square brackets up here, it means moles per liter. So we need to divide each of these by 10. So I'm going to add another row onto the bottom of my table, E over V. And you need to divide each of these concentrations by 10 because it is a 10-liter container. We're dividing it by 10 because we want to get the number of moles present in 1 liter. So 6.0 divided by 10, 18.0 divided by 10, and 6.0 divided by 10. So that means at equilibrium in moles per liter, I actually have 0.6 moles of my hydrogen. I have 1.8 moles of my hydrogen, and I have 0.6 moles of my ammonia. At equilibrium, that's what will be present in the jar. So now I must go and I must calculate my Kc. So you have to calculate the value of Kc. So now we need to fill in all of these values into our Kc formula. So I know on the top of my line, I put in the concentration of my ammonia, which is 0.6, and that has to be squared. Then I have to divide that by the concentration of my nitrogen, which is 0.6 raised to the power of 1, and my hydrogen, which is 1.8 raised to the power of 3. So if we go and continue that calculation, then we would see that we end up with 0.38, if you put it into the calculator, over 0.6 by 5.832. And when we put all that into the calculator, we get 0.1085. So I'm going to round that as 0.109. And that is my Kc value. So I'm going to box that off in yellow. That is the Kc value. That is the answer. Now, from our theory of what we learned earlier on with our Kc value, we know that the Kc value is very, very small, that the equilibrium very much lies to the left. So that would mean that the backward reaction is favored. So I'm just going to write that down here. Kc value is less than 1, therefore equilibrium lies to the left. So that means there is more products present than there is reactants. Now, the last part we want to do then is we want to do part 3. So I'm going to do part 3 in a little box here. I'm just putting it in a box so that you can identify it. So for part 3, it says, it asks you to find the percentage by volume of ammonia in the container at equilibrium. So you want to find what percentage of ammonia is present in the container at equilibrium. So at equilibrium, I know I have 0.6 moles of my nitrogen plus 1.8 grams of my hydrogen plus 0.6 grams of my ammonia. So I know that there's 3 moles in total in my flask at equilibrium, and we want to find what percentage of that 3 moles is just ammonia. So we know that for the ammonia there was only 0.6 of it, so we can do 0.6 over our 3.0, and if we multiply that by 100, it tells us that there was 20% of the contents of the container consists of ammonia. And that should make sense, because that means there's 20% of our product. So consequently, there would be 80% of our reactants. And that matches up with my equilibrium constant because it's less than 1. So the equilibrium is lying to the left, meaning that there is more reactants present, which would be very true because I only have produced 20% of my product. So that is calculation type 1 of equilibrium, where you are asked to calculate the Kc value when you are given the concentrations. So what we're going to do now is we're going to do type 2, and type 2 is where you have to calculate the concentration of a particular molecule when you are given the Kc value. And this is worth 12 marks. So not as much of marks for the equilibrium calculation in 2020, but still a substantial amount, still 4%. That 4% would be a big difference between a H1 and a H2. So again, important to be able to do this calculation. So let's read through it slowly to begin. It says that when 3 moles of carbon monoxide and 1 mole of steam were mixed together in a container of fixed volume V, and in the presence of a suitable catalyst, the following chemical equilibrium was established at a temperature of 800 Kelvin. And they've given you your equation there. They've then said that the equilibrium constant for this reaction was 4.0, and they've asked you to calculate the number of moles of carbon monoxide. So with this question, you are going to have to use your Rice equation to find all of your concentrations in moles per liter at equilibrium, as much of them as you can, and you need to let that then equal 4 and work backwards. So let's have a look at that. So the first thing I would always do in a question like this is I would write down my Kc value. So the Kc value, or my Kc formula expression. So my Kc formula here is Kc is equal to CO2 to the power of 1 by H2 to the power of 1. So that's my products. And again, I divide that by my reactants. So my reactants, it's CO to the power of 1 and H2O to the power of 1. And I know I'm going to write that down, that is equal to 4.0. And that's going to be very helpful to us when we come to the end of our calculations. So in order to calculate the number of moles of carbon monoxide, we need to go and we need to do our Rice table, and then fill as much into the Kc formula as we can, because what we're looking to find at the end is we're going to hope that we can find the volume of the carbon monoxide that I've highlighted there for you in yellow. Now, just to be aware here, the fixed volume is V. So because they say that the volume is V, I tend to ignore it. Unless they give you a figure for volume, I wouldn't be divided by it further down in your rice table. So let's do our rice table. So I'm going to do the headings of it here in yellow. So you've got R, I, C, and E. Okay. So R stands for reaction. So that will be the first thing that I will be writing out, the reaction. So the reaction here is CO, H2O. They're my reactants, and then my products are CO2 and H2. So it tells me that 3 moles of my carbon monoxide, 3.0, react with 1 mole of steam. Steam refers to water. And we filled those into our initial row because that initial means what we have at the start. And we know at the start of any reaction, you won't have any product unless you're told otherwise. So we can fill in 0 and 0 for our products. Now, when you're calculating your Kc value, when you're calculating a concentration, when you're given the Kc value, you do fill in the change column next. Now, it's important that you understand this is a 1:1:1:1 ratio, because this will be important for your change. So we know that the change, when you are undergoing a reaction, your reactants are going to react to produce a product. So the concentration of your reactants will decrease and the concentration of your products will consequently increase. Now, we don't know how much that these concentrations decrease by, so we're just going to give them a value, X. So X, because it's a 1:1:1:1 ratio, all of these would be X. Now, just to be aware, I'm just going to rub out for 1 second. If this was 2H2 as follows. So if this was 2H2, we would have a 1:1:1:2 ratio. You'd still have 0 here. This would be an increase of 2x because it would be, you've twice as much hydrogen as you do carbon dioxide. So just that you're aware of that, if the ratio isn't 1:1:1:1 like it is here. If there's numbers in your ratio, like 1:2, 2 just twice as much of the X, but we don't need to worry about that here. I'm going to undo all of that. This is what we have here because it's a 1:1:1 ratio. So now let's get our concentration at equilibrium the exact same way as you got it in the previous question by putting your initial and your change together. So what you'll end up with is you'll end up with 3 minus X, 1 minus X, X plus X, and plus X. So they are all of your equilibrium concentrations done for you there. Okay, so now you have your equilibrium concentrations. You go and you fill into your Kc value. So we know that our Kc is equal to the concentration of the carbon dioxide. The concentration of the carbon dioxide is X, and that's raised to the power of 1. Multiplied by the concentration of the hydrogen, that's the other product, X to the power of 1. And that's divided by the concentration of the carbon monoxide, which is 3 minus X, again, raised to the power of 1, multiplied by the concentration of the water or the steam, 1 minus X, which is again raised to the power of 1. And we know that that's equal to 4.0. Now, once you get to this point here, I would recommend that you do a cross multiplication or multiply both sides by the denominator. Apologies, multiply both sides by the denominator to get rid of it. So this Kc value would become X by X equals 4.0 by 3 minus X by minus X. Just ignore the powers there because they're all to the power of 1. So now we need to go and we need to do some multiplication on this. So the first little piece is easy. X by X is X squared, and that's going to be multiplied by 4 into something. So I need to go and do some multiplication now on my 3 minus X and 1 minus X. So we want to do 3 minus x multiplied by 1 minus x. Now, the way I do this, you can do the distributive method if you want, but I tend to do the array model or the area model. Some of you may be familiar with it. So I will put my 3 minus x on one side of my square and 1 minus x on the other side. And I will go and do my multiplication that way. So 3 multiplying the area basically of each square. 3 minus 1 is 3. 3 by minus x is minus 3x. 1 by minus x is minus 1x. And minus by minus is plus. X by x is x squared. So that gives me x squared minus x minus 3x plus 3. So that is x squared minus 4x plus 3. And what I do now is I go and I fill that in. So it's going to be 4 by x squared minus 4x plus 3. And what that's going to give me then is it's going to give me x squared is equal to 4x squared minus 16x plus 12. Now, here you can see we're going to start forming a quadratic equation. So if we let it equal to 0 and bring everything to one side, we end up with 3x squared minus 16x plus 12 is equal to 0. Now, at that point, I would recommend that you go and use the minus b formula on this. So I would be doing the minus b. So I'm just going to zoom in for a second. I'm just going to put a line under that, and I'm going to write out 3x squared minus 16x plus 12 equals 0. So now I would go and do the minus b on that. So we know that the minus b formula is x equals minus b plus or minus the square root of b squared minus 4ac. And you divide that by 2a. And we know that a is equal to 3, b is equal to minus 16, and c is equal to 12. And just be careful when you're filling that in. So we will get x is equal to minus 16 plus or minus the square root of minus 16 squared minus 4 by 3 by 12 all over 2 by 3. So that gives me, when I put some of this into the calculator, it gives me 16 plus or minus the square root of 256 minus 144, and that's divided by 6. So that's equal to 16 plus or minus the square root of 112 over 6. Now, there's two possibilities here then. So x could be equal to 16 plus the square root of 112 over 6, or x could be equal to 16 minus the square root of 112 over 6. When you put those into the calculator, you get that x is equal to 4.43, or x is equal to 0.9. Now, if I zoom back out here for us into our question, I can see that my initial concentration, okay, of my reactants, the largest initial concentration was 3. So x cannot be 4.43, because if we put x in here, you would have 3, take away 4.43, and that would give you a negative concentration of your carbon monoxide, which is physically impossible. So your x value has to be 0.9. It cannot be the 4.43, because if we put in the 4.43, that will give me a negative concentration at equilibrium, which is physically impossible. So now that we have that, we can go and find our equilibrium concentrations. So what I will be doing is I will be rewriting out my equation here. I would have CO, I would have H2O, I would have CO2, and I would have H2, like that. And I know that at equilibrium, I have 3 minus x, I have 1 minus x, I have plus x and plus x. So I would fill all of these in. So I have 3 minus 0.9, which is 2.1. I have 1 minus 0.9, which is 0.1. And that goes to plus 0.9 and plus 0.9. So they're all of my concentrations at equilibrium. And you are asked for the concentration of, or to calculate the number of moles of carbon monoxide at equilibrium. So the number of moles of carbon monoxide at equilibrium is 2.1, and I've just boxed it off there, and I will also highlight it for you. So that is your answer to find the concentration of your carbon monoxide at equilibrium. So that is your equilibrium calculations completed, with 2 exam solutions done out for you to look at. And I would recommend you go back over these in your own time, maybe try the question again yourself and see if you get the correct answer based off these worked solutions. So before we go, today I just have one more job. I just want to quickly show you around the ExamRevision website. So this is what the ExamRevision website looks like. So when you log into the ExamRevision website, this will be what you'll see. So this is what you would see if you log in and you sign up to ExamRevision. And ExamRevision have multiple subjects that you can choose from. So this is a list of them here. You have junior cycle, business, geography, home economics, maths, science, or for Leaving Cert, which you are more interested in, there's ag science, biology, business, chemistry, economics, English, French, geography, history, Irish, maths, music, and physics. But we're interested in the chemistry one today. So when you click into that video tutorials, what it will do is it will bring you to the complete chemistry course done out into sections. So for example, if you're interested maybe in looking at titration technique and calculations that we looked at today, you will click unit 4 and it will bring you into titration techniques and some sample calculations. So in that, we have titration techniques. So this video explores equipment used in titration and the correct technique to use it. And it basically goes through all of the different parts of how to use your correct titration technique. Similarly, there's a self-correcting quiz, there's a PowerPoint presentation, and there's also H1 standard notes there for you to be able to use yourself. So the H1 notes are there for you. And if I keep going back here, then it brings us, we get brought back here then to our page again. And if we go into equilibrium then, in here you'll see there's an introduction to Le Chateliers Principle. There is an experiment on Le Chateliers Principle. The Haber process is covered, and then there's also some stuff on the equilibrium constants that we would have looked at today. Again, quizzes, presentations, and your resource pack with your H1 standard notes. And that is done for all chapters on the course. So if we go into organic chemistry, then it's split into fuels and families and reactions. So if you go into the reactions, I have all of the reactions done out for you, including experiments on the preparation of soap, the properties of the ethanol, the properties of the ethanoic acid, and the recrystallization of benzoic acid. There's 2 quizzes, and you have your PowerPoint presentation and your power pack. So that's just a quick look around the ExamRevision website for you. So if you wish to sign up to the ExamRevision website, you can get a free account, and this will give you a sample trial of the subjects on the website. So this will give you access to one topic. But if you move on to the standard or the premium plans, that's when you start to get all of your PowerPoints, your videos, your mock and exam questions are there, all the marking schemes, and that's on the standard plan. But the premium plan then gives you access to the self-correcting quizzes and stuff like that. So you can, it's $19.99 per month, so €20 a month. And if you sign up for multiple subjects, then you can get a discount, etc. And you'll be glad to hear that today I'm able to give you a further discount on that price. So if you use the code Robert20 before tomorrow evening, Sunday the 8th of May at 23:59, it will give you 20% off your standard and premium plan prices. So if you use the code Robert20, it will give you 20% off the prices that you've just seen there. I recommend it. It would be particularly useful in the last month now leading up to your Leaving Cert exam, when you might be studying from home. You would have full access to the videos and be able to hear a teacher, myself, speak through notes and give explanations of all of the topics on the Leaving Cert Chemistry course. So that's it for our Saturday session for today. I wish you all the very best of luck with your Leaving Cert Chemistry exam. You'll find ExamRevision on all of the social media platforms and YouTube. We're on Twitter, Instagram, TikTok, and Facebook. Keep an eye out for some competitions that we run for free accounts or free access to revision courses, etc. if you've any younger siblings. And I do wish you the very best of luck with your Leaving Cert exam, and all the best. Thanks a million for joining today, and hopefully we'll see you at the next Saturday session coming up next week. Okay, thanks a million, guys.